So let's continue talking about area. So we're in section 5.2. And we're going to start by talking about summation notation. So the sum of A1, A2, A3 up to AN is written as sigma, so this big sigma, I from 1 to n of AI. So this again represents A1, A2 plus A3 all the way up to AN. So this number down here, this 1, this is called your lower bound. It's your starting value for I. And then this n here, this is your upper bound. So this is your ending value for I. And then we call I the index of the summation. So it's your variable. And then we would call the term AI the ith term. So let's look at some examples with summation notation. So the first one, the sum from I equals 1 to 6 of I. So we're going to start off, look at your lower bound as 1. That's your starting value for I. And your upper bound is 6. That's your ending value for I. And so you're going to take your formula here and plug in those numbers into I. So you're going to start with 1 and then plug in 2, 3, 4, 5, and 6. And that's the end of your, you've reached your upper bound now. And so you're going to add up all these numbers and the sum will be 21. So let's look at our next one. A summation from j equals 3 to 7 of j squared. So again, look here, my lower bound is 3. So that's going to be my starting point. And then I'm going to stop when I get to this upper bound of 7. So now in your formula, you're going to start by plugging in 3. So 3 squared plus 4 squared plus 5 squared plus 6 squared plus 7 squared. And you're going to stop because we've reached our upper bound. And you're going to add all these numbers together. And you will get 135 for this sum. Okay, so now for part C, so we're going to look at the sum from k equals 1 to n, 1 over n, k squared plus 1. So here, really your index variable is k, and you're going to start off with k equals 1, and then you're going to end at the value n. So n here represents some fixed number. So I'm going to start, when I write this sum, start by plugging in k equals 1, 1 over n, 1 squared plus 1. And then the next value for k would be 2, 1 over n, 2 squared plus 1. And you keep going until you get to your last term where you're going to plug in n for k. So it'll be 1 over n, n squared plus 1. And that would be my sum. And it's not a specific value because we don't know what n is here. Once you fix a value of n, this would become a fixed number. Let's look at one more of these. So if I have I equals 1 to n of f of xi delta x, so again, you start off with your lower bound, here's 1, and you keep going until you get to your upper bound of n. So you're going to plug in 1, f of x1 delta x, plus f of x2 delta x, and you keep going until you plug in the final value, which is n, so it'll be f of xn delta x. And that would be the summation. Again, it's not a specific value here, but we start with our lower bound of 1 and build up to our upper bound of n. So the last thing we're going to do in this video is go over the properties of our summation here, notation. So if I have I equals 1 to n, k times ai, and k is just a constant, you can pull it out. So I'll say k is a constant. You can pull it out of a summation. And then our second property is that you can split up sums and differences. So if I have ai plus or minus bi, you can split this up into two summations. The summation of ai plus or minus the summation of bi. And really all you're doing is if you write down this left-hand side and this right-hand side, you'll see that it has the same terms, but they've been rearranged. But addition and subtraction are commutative properties, so you can rearrange addition and subtraction.